Voyager 1 is now so far from Earth that its signal needs more than 22 hours to reach us. Every command we send leaves this planet as a faint radio whisper, crosses the orbit of the Moon in a little over a second, passes Mars, Jupiter, Saturn, Uranus, and Neptune, and then keeps going into a darkness no human being has ever entered. When that command finally reaches the spacecraft, Voyager answers with a transmitter weaker than a refrigerator light bulb. By the time the signal comes home, it is almost gone. And still, we hear it. That is the strange power of Voyager 1. It is not just a machine. It is a moving boundary marker for the human story. It was built to study planets. It became the first spacecraft to touch interstellar space. And if physics allows it to survive as an object, long after its electricity fades, long after its last instrument goes silent, it will continue carrying evidence that a small blue world once made something and sent it outward. The mission began with a rare alignment. In the late 20th century, the giant planets happened to be arranged in a way that would not repeat for many human lifetimes. A spacecraft could fly from one world to the next, borrowing speed from gravity, turning the planets themselves into stepping stones. The idea was called the Grand Tour. It was bold, almost reckless, and exactly the sort of opportunity that spaceflight exists to take. Voyager 1 launched in 1977, 2 weeks after its twin, Voyager 2. The rocket did not simply push a probe into space. It launched a chain of events that would stretch from the cloud tops of Jupiter to the invisible edge of the Sun's influence. The spacecraft was compact, practical, and strangely beautiful. In the way scientific machines can be beautiful, a bus full of instruments, a high-gain antenna like a white dish, a long magnetometer boom, radio isotope generators for power, and cameras that would soon show humanity worlds it had never truly seen. Bolted to its side was something no engineering requirement could fully explain: the golden record. It was a message, a time capsule, and a work of optimism. It held images of Earth, greetings in many languages, music, natural sounds, and diagrams explaining where we are. It did not assume anyone would find it. It simply said that if someone ever did, there had once been minds here that wondered, listened, measured, loved, and tried to speak across the dark. Voyager 1's first great target was Jupiter. From Earth, Jupiter is a bright point, a wandering star. Up close, it becomes a weather system larger than imagination. Voyager's cameras revealed bands of cloud moving in opposite directions, storms rising and folding into each other, lightning inside a world with no solid surface, and the Great Red Spot, an ancient storm wide enough to swallow Earth. But the biggest surprise was not Jupiter itself. It was Io. Before Voyager, no one had seen active volcanoes beyond Earth. Then the images came back, and scientists noticed plumes rising from the Moon's surface. Io was alive with geology, heated by tidal forces as Jupiter and the other moons needed its interior. A place once expected to be cold and dead turned out to be violent, sulfurous, and constantly remade. Voyager also looked at Europa, Ganymede, and Callisto. Europa appeared bright and smooth, crossed by dark lines like fractures in ice. Ganymede showed grooved terrain, evidence of a complicated history. Callisto looked ancient, cratered, and battered. The lesson was immediate. Moons were not simple leftovers. They were worlds, each with its own story. Jupiter also gave Voyager what it needed most: speed. The spacecraft curved through the planet's gravity field and stole a tiny part of Jupiter's orbital energy. Jupiter did not notice. Voyager did. Its path bent outward, faster and farther, toward Saturn. Saturn arrived as a pale globe wrapped in a system of rings that looked delicate from a distance and became impossibly complex up close. Voyager saw ringlets, gaps, waves, edges, and braided structures. The rings were not a single smooth band. They were a vast moving disk of ice and dust, shaped by gravity, resonance, and the small moons embedded near them. Saturn's moons deepened the mystery. Some shepherded the rings. Others carried scars from ancient impacts. But the mission's most important target was Titan. Titan was larger than Mercury and covered by a thick orange atmosphere. Its surface was hidden, but the atmosphere itself was a prize. Nitrogen, methane, and complex hydrocarbons made Titan feel less like an ordinary moon and more like a chemistry experiment running in the cold. The Titan flyby changed Voyager 1 forever. The geometry that let it pass close to Titan also bent the spacecraft out of the plane of the planets. From that moment, it would not continue to Uranus or Neptune. Voyager 2 would make those visits. Voyager 1 would take the faster road out of the solar system. In 1990, after its planetary mission had ended, Voyager 1 performed one last act of seeing. Engineers turned the spacecraft back toward the inner solar system. From nearly 6 billion kilometers away, it photographed the planets as tiny points in scattered sunlight. Earth appeared as less than a pixel, the pale blue dot. That image did not show continents or oceans. It did not show borders. It did not show cities, armies, arguments, monuments, or names. It showed a mote of light suspended in a sunbeam. Every person who had ever lived, every language, every triumph, every mistake, every ordinary morning, every private grief, all of it was there. The photograph was not scientifically necessary in the usual sense. It was necessary in a human sense. After that portrait, Voyager's cameras were turned off. Power had to be saved for instruments that could still measure the environment ahead. The spacecraft kept moving at roughly 17 kilometers per second, leaving the planets behind and heading toward a frontier that had never been crossed. That frontier was the heliopause. The sun blows a continuous stream of charged particles called the solar wind. That wind inflates a vast bubble around the solar system, the heliosphere. Inside it, the sun dominates the space environment. Outside it, the spacecraft begins to feel the interstellar medium, the thin material between the stars. Crossing the heliopause was not like crossing a line painted in space. There was no visible wall, no sudden flash, no cinematic doorway. Voyager detected the change through particles. The number of particles from inside the solar system fell. Galactic cosmic rays increased. The magnetic environment shifted. In 2012, Voyager 1 became the first human-made object known to enter interstellar space. The phrase sounds simple, but it is enormous. Interstellar space is not empty. It is thin beyond human intuition, yet full of fields, rays, dust, atoms, and memory. Voyager was now inside the wider galaxy, no longer protected in the same way by the sun's wind. It had become a probe not of planets, but of the space between stars. Even there, the mission remained practical. Voyager measured plasma waves, magnetic fields, energetic particles, and cosmic rays. Those numbers told scientists what the outer edge of the heliosphere was like from the inside out. They helped answer a question that sounds simple only until we try to measure it. Where does the solar system end? Not where the last planet orbits, and not where the sun stops shining, but where the sun can no longer push back the galaxy around it. That boundary is not a sphere as clean as a diagram. It is shaped by the sun's motion through the galaxy, by the pressure of interstellar material, by magnetic fields, and by the changing strength of the solar wind. Voyager 1 gave us one path through that boundary. Voyager 2 gave us another. Together, they turned the edge of the solar system from an idea into a place with data. The data is fragile because the spacecraft is fragile. A tiny error in memory, a shift in a thruster, a weak heater, a software workaround written decades after launch, each one can decide whether the mission continues. Engineers now work with hardware older than many of the people operating it. They read old documents, rebuild forgotten procedures, and send instructions across more than 20 billion kilometers to a machine that answers nearly 2 days later. That delay changes the meaning of control. Nothing about Voyager is immediate anymore. A command is an act of trust. The team sends it, waits, and listens. If the spacecraft responds, the mission earns another day. If it does not, the only option is to reason from silence. In a world built around instant communication, Voyager is a reminder that exploration can still move at the speed of patience. The spacecraft is old now. Every year, its plutonium power source produces less electricity. Engineers have already turned off heaters, backup systems, and instruments one by one. Each decision is a trade. Keep this sensor alive. Lose that margin of safety. Save this watt. Give up that comfort. The mission has become an exercise in patience and care. At some point, probably within the next decade or so, Voyager 1 will no longer have enough power to operate any science instrument. After that, the transmitter may fall silent. There will be no final explosion, no dramatic ending. One day, Earth will listen and receive nothing. The spacecraft will still be there, but the conversation will be over. For a machine, silence is not death in the way we experience it. Voyager will keep moving. Its antenna will still point along a path chosen long ago. The golden record will remain attached. The metal will cool. The electronics will become inert. Micrometeoroids may pit the surface. Radiation will leave scars invisible to the eye. But the spacecraft will continue because nothing in its path is likely to stop it. That is where the story changes scale. While Voyager can still talk, we measure it in watts, bits per second, antenna angles, and instrument modes. After silence, we measure it in centuries, millennia, and orbital paths through the galaxy. It becomes less like a spacecraft and more like an archaeological object that escaped its planet before the museum burned down. Most human artifacts are protected by being kept close. We place them in libraries, vaults, archives, temples, hard drives, museums, and climate-controlled rooms. Voyager is protected by distance. It is safe not because it is guarded, but because it is alone. Space is so empty that loneliness becomes a kind of preservation. 40,000 years from now, Voyager 1 will pass within a few light years of another star. That sounds close until we remember the scale. A few light years is still tens of trillions of kilometers. It will not enter a new solar system. It will not slow down and orbit. It will simply drift past, a silent artifact moving through the outskirts of someone else's sky. By then, Earth will be different beyond recognition. Languages will have changed. Nations will be gone or transformed. The people who built Voyager will be ancient history. The spacecraft will not know any of this. It will carry its record as it always has, with no awareness of what it means. Millions of years pass. Stars shift position. Constellations lose their familiar shapes. The Sun continues its orbit around the center of the Milky Way. Voyager moves through the galactic disk, occasionally nudged by gravity, always too small to matter and too persistent to ignore. In hundreds of millions of years, the continents of Earth rearrange. Oceans open and close. Species rise and vanish. The sun slowly brightens. The climate history of Earth becomes more extreme. The blue world that launched Voyager becomes harder and harder to recognize. In about 1 billion years, the sun's increasing brightness may make Earth hostile to complex life. Long before the sun becomes a red giant, the balance that made oceans stable begins to fail. The planet that sent out greetings to the stars may lose the conditions that allowed those greetings to be made. If life still exists here, it may be forced into refugees. If intelligence still exists, it may have left, adapted, or become something we would not recognize. None of that future is guaranteed. But Voyager makes the question physical. It is a piece of our era already outside the fragile zone where Earth's fate will be decided. It has crossed a kind of insurance line, not for survival of our species, but for survival of a message. The message is not a complete record of humanity. It could never be. It does not explain every culture, every conflict, every contradiction, every kindness, every terror, every ordinary detail that makes a civilization real. It is selective, hopeful, and incomplete. But that imperfection is part of its truth. The golden record is not a final answer. It is a gesture made by a young spacefaring species that did not know how long it would last. Several billion years from now, the sun will swell. Mercury and Venus will be consumed or ruined. Earth may be scorched beyond repair, perhaps engulfed, perhaps left as a burnt remnant. The inner solar system will become a place of heat and loss, but Voyager will be far away, untouched by that transformation, still traveling through the galaxy. The sun will eventually shed its outer layers and leave behind a white dwarf, a dense ember, no longer the star that warmed oceans and fed forests. Around it, the remains of the solar system will continue in altered orbits. The world that built Voyager may be gone, yet the spacecraft will remain one of the few physical objects from our age still intact enough to tell a story. The Milky Way itself will not stay unchanged. It is on a slow collision course with the Andromeda Galaxy. Over billions of years, the two great spirals will pass through each other and merge. Stars are so far apart that direct collisions will be rare, but gravity will reshape everything. The night sky, if anyone is watching from somewhere, will become a storm of stars. Voyager will be there for that too, not as a participant, but as debris with a history. It may be pulled into a new orbit around the merged galaxy. It may pass through regions of gas and dust. It may spend ages in darkness between star systems. The odds of being struck by anything large are tiny because space is brutally empty. It may also be changed in ways too slow for drama. Cosmic rays can alter materials, atom by atom. Dust grains moving at enormous speeds can leave microscopic impacts. Temperature swings and radiation can weaken surfaces. The record cover may become scratched. The grooves may degrade. The spacecraft may tumble. Even so, destruction is not the default. On these scales, survival does not require strength in the familiar sense. It requires avoiding collision, and the universe offers a lot of room. Then the timescales become almost impossible. Trillions of years from now, star formation will slow and then fade. The bright, short-lived stars will be gone. Long-lived red dwarfs will burn for immense stretches of time, but even they will eventually exhaust their fuel. The universe will become darker, colder, and quieter. 10 trillion years is not just far in the future. It is beyond almost every story humans naturally tell. Empires, languages, species planets, and stars all begin to feel temporary. In that age, if Voyager still exists, it will be older than the Milky Way is today. The record it carries may be unreadable, or it may still contain enough structure for some impossible future intelligence to notice that it was made. And if no one ever notices, the meaning does not vanish. A message can matter even when it is not received. The act of sending Voyager outward changed the people who sent it. It forced us to look at planets as worlds, at Earth as a small point, and at time as something larger than civilization. It made the solar system feel like a place we could travel through, not just a pattern of lights. Voyager 1 was not built for this future. No engineer designed it to last 10 trillion years. Its electronics will fail. Its surfaces will erode. Its record may be damaged. But as an object, as a shaped piece of matter, it could persist for lengths of time that make civilization feel like a spark. The golden record is the most fragile part of the dream and the most haunting. If it survives, it may outlast every library, every server, every monument, every archive on Earth. It may become the oldest readable message humanity ever made, not because it was protected by a vault, but because it was thrown into the emptiest place we could reach. The chance that anyone finds it is almost zero. That does not make it meaningless. Meaning is not always measured by arrival. Sometimes it is measured by the attempt. Voyager says that at least once, a species looked up from its own world and decided to send a greeting without knowing who, if anyone, would ever receive it. That is why the spacecraft still matters. It is a scientific instrument, a historical artifact, and a philosophical question moving at 17 kilometers per second. It asks what survives when voices fade. It asks whether exploration is only about useful data, or also about leaving evidence that curiosity existed. Right now, Voyager 1 is still out there. It is beyond the planets, beyond the easy maps, beyond the region where sunlight feels like sunlight. It is old, cold, and fragile, and yet it is still moving, carrying a tiny archive of Earth into a future we cannot enter. One day, the signal will stop. The screens on Earth will show no new data. The mission will become history. But the spacecraft will continue without us, past the sun's fading influence, past stars not yet born, through a galaxy that will change, shape, into a universe growing slower and darker. And somewhere in that silence, whether or not it is ever found, Voyager 1 will still be saying the same thing it said when it left. We were here, we looked outward, and for a moment in cosmic time, we tried to be known.